Namaste everyone. In this video we shall see how to add two vectors. So addition of vectors cannot be done algebraically. Addition of vectors should be done geometrically. So what do you mean by adding the two vectors geometrically, and how to add vectors is what we'll be learning in this video. If the vectors are in the same direction, let's say there are two vectors. Let us assume the two vectors are a and b. This is how we represent the vectors, and vectors are the quantities which have magnitude and direction. So whenever we have to say something about a vector, we need to tell what is its magnitude and we need to tell what is its direction also. Now as you can see, here the two vectors a and b are in the same direction, so the addition of vectors is very simple. You just need to add the magnitude and the direction remains same. And if the vectors are in opposite directions, this is vector a, this is vector b, as you can see they're in opposite directions. In such cases we just need to subtract the magnitude of the two vectors, and the direction of the resultant vector will be same as the direction of the larger vector or the vector with greater magnitude. The addition of vectors becomes simple when the two vectors are in the same direction or when the two vectors are in opposite direction. But if the two vectors make an angle like this, for example, let's say this is the direction of vector a, let's say there is vector b like this is vector b. Now as you can see, the two vectors are not in the same direction nor they are in the opposite direction. In fact, they are making an angle with respect to each other. You can observe there are two angles here, this angle and this angle. So which angle should we consider? So we should consider the smaller angle. Let's represent the smaller angle between the two vectors as theta. Theta is the angle between the two vectors. Theta is the angle between the two vectors. So we need to find out what is the resultant vector. So let the resultant vector be C, like this. So from here to here, let the resultant vector be C. So it's the resultant vector. Now we need to find out what is vector C. We need to tell what is its magnitude and we need to tell what is its direction. So here vector C is nothing but it is obtained by adding the two vectors A and B. How do we find it? For that we'll see how we can derive a formula to find the magnitude of vector C and the direction of vector C. For that, what we will do is we will just create a triangle here and we will use a law called as triangle law of addition of vectors. Triangle law of addition of vectors. So this law, triangle law of addition of vectors, will help in determining the magnitude of the resultant vector C and its direction. For this, we'll take the help of construction. We'll construct in such a way that this is 90 degrees, this is 90 degrees. Now for convenience I will label this as O, this point as O, this point as say P, this point as Q, this point as R. So as you can see, if you find the length of this RP, it will give us the magnitude of vector C. Length of RP will give us the magnitude of vector C. For that, first we shall consider the triangle POQ. First we shall consider the triangle POQ. In a right triangle POQ. Why are we considering the right triangle only? Is here we will be using some trigonometric ratios, that is cos and sine, and these trigonometric ratios we have learnt that they are defined for a right angle triangle. So we have taken the help of construction and created a right angle triangle, and that right angle triangle is POQ. Now what is cos theta? Cos theta is adjacent by hypotenuse. For this triangle, adjacent is OQ and the hypotenuse is PQ. So what is PQ? So PQ will be OQ by cos theta, or what is OQ? OQ will be PQ cos theta. PQ cos theta. And what does PQ represent? It's, if I take the length of PQ, PQ represents the magnitude of vector B. So in place of P, I'll write B cos theta. So what is P? What is B here? It is magnitude of vector B. Now let's take, in the same right angle triangle, let's take what is tan theta. So or rather sin theta, I must say. Sin theta is opposite by hypotenuse. So what is opposite here? It is OP by hypotenuse PQ. So what is OP here? OP will be equal to PQ sin theta. OP is equal to PQ sin theta. What does PQ represent here? What does PQ represent? PQ again represents the magnitude of vector B, which is nothing but B sin theta. B sin theta. So let's call this as equation 1. Let's call this as equation 2. Now what is that we need to find out? We need to find out the resultant. We need to find out the formula to find the magnitude of the resultant vector C. So how do we find it? As I told before, magnitude of vector C is represented by the length of this PR. If I consider the triangle POR, you can observe that PR is the side opposite to a right angle, and therefore PR is the hypotenuse of triangle POR. So therefore the length of hypotenuse of the triangle POR will give us the magnitude of a vector C. So let's find out what is the length of length of the hypotenuse PR. For that we shall consider the right triangle again, that is in right triangle POQ. Let's apply Pythagoras theorem. By Pythagoras theorem, PR square is equal to OR square plus PO square. OR square plus PO square. Now PR, as I told, is representing the magnitude of vector C. So I'll write it as C square, capital C square, where capital C represents the magnitude of vector C. So OR, if you observe carefully, can be written as RQ plus QO. RQ plus QO. RQ plus QO. But there is square here, so square plus PO square plus PO square. I'll write PO square as PO square itself. Next, we will see what to do next. So we just need to substitute the values of RQ and QO and PO, and we can find out what is the formula to calculate the magnitude of vector C. So I'll just rewrite this. C square is equal to RQ plus QO whole square plus PO square. I've just written the previous step here. This one I have rewritten here. Now what is RQ? RQ is representing the magnitude of vector A. So I'll write A. What is QO? From equation 1, QO or OQ is nothing but B cos theta. So I'll write B cos theta here. But there is whole square, so I'll write whole square. Now from equation 2, you see that this OP or PO is equal to B sin theta. So I shall write B sin theta here, but there is square here, so B sin theta whole square. Now so how did we write this? This is from equations 1 and 2, from equations 1 and 2. And what does A represent? A here is magnitude of vector A. Magnitude of vector A. So we just need to simplify this equation further. Here I shall expand this A plus B cos theta whole square by using the algebraic identity A plus B whole square, which is nothing but A square plus B square plus 2AB. So using A plus B whole square is equal to A square plus 2AB plus B square. So I can write this as A square plus 2AB cos theta plus B square, that is B square cos square theta, plus here this can be written as B square sin square theta. I've applied square to this as well as this. So what is the identity we have used? We have used the algebraic identity A plus B whole square is equal to A square plus 2AB plus B square to expand this. Now let's see what we can simplify. A square plus 2AB cos theta. Now B square cos square theta plus B square sin square theta. From these two terms I can take B square common, and what is left out? Cos square theta plus sin square theta is left in the bracket. So we know that cos square theta plus sin square theta is equal to 1. This is one of the trigonometric identities we have learned. So therefore C square will be equal to A square plus 2AB cos theta plus B square. Cos square theta plus sin square theta is 1, so it will be B square into 1, which is B square. Or C will be equal to A square plus, I'll just rearrange these terms, plus B square plus 2AB cos theta. So I'm just rearranging these terms so that it becomes easy to remember. So to find this is resultant, or it's the magnitude of resultant vector. So to find the magnitude of resultant vector, we can use this formula. C is equal to square root of A square plus B square plus 2AB cos theta. Suppose I want to know what is the direction. What is the direction of the vector, resultant vector C? Let's say it makes an angle. It means the resultant vector makes an angle of alpha with respect to the first vector. What is the first vector here? Vector A. So let the angle between vector A and resultant vector, no need to write this, it's understood, vector A and resultant vector C be alpha. So if you can tell us the value of alpha, we can even tell what is the direction of the vector C. So we know how to find the magnitude already by using this formula. As a vector, as we know, vector has a magnitude and direction. We need to tell its direction. If you know how to find the value of alpha, we can say that the direction of vector C is such that it makes an angle alpha with respect to the horizontal or with respect to the vector A. In this way, we'll be able to tell its direction as well. So we need to derive a formula to calculate alpha, which is nothing but the angle between the resultant vector C and the first vector, that is A. So for that, again we shall take this right triangle only. In right triangle POR, in right triangle POR, in right triangle POR, in right triangle POR. So tan alpha will be opposite. In general, tan is opposite by adjacent. Opposite is OP, adjacent is RO. So tan alpha will be equal to tan alpha will be equal to, what is OP? From equation 1 or equation 2, from equation 2, OP is B sin theta. So in place of OP, I'll write B sin theta divided by, what is RO? RO is nothing but A RQ plus QO. I've written here. RO or OR is nothing but RQ plus QO. And this RQ is nothing but A, and QO from equation 1 is B cos theta. So I should write RO as RQ plus QO. And what is RQ? It is A plus QO. QO, as you can see, is nothing but B cos theta. I shall write B cos theta. So in this way, this formula can be used to determine the value of alpha, the value of tan alpha. From tan alpha, we can easily determine what is the value of alpha and tell what is the direction of the resultant vector C. And again, alpha is the angle made by the resultant vector C with respect to A. So in this way, we will be able to add two vectors. We'll be able to add two vectors using a law called as triangle law of addition of vectors, and determine the magnitude of the resultant vector as well as the direction of the resultant vector. So we shall, in the upcoming videos, we shall solve numerical problems using these two formulae and find the magnitude of the resultant vector and the direction of the resultant vector. Thank you for watching. Please subscribe, like and share. Share these videos a lot so that it will help the students who are unable to get access to good teaching. Thank you very much.